In lesson 1.5, we're going to work on applying some equations, solving equations, and we're going to do that by looking at some word problems. And so we have some general guidelines here for attacking word problems. It's a four-step thing, which is very well known. First, it's read, plan, solve, and check. So you want to read carefully, noting important words, key phrases, the type of problem, if that fits, and assign a variable to the main unknown. And that's the one that other things are being compared to. Next, we're going to make a plan. So if there's any other unknowns, we're going to describe any other unknowns in terms of the variable we've chosen. And we're going to organize the information in tables or diagrams, or even draw a picture if possible. We might even draw a picture up in the first part. Step 3 is solve. So we want to find a relationship, an equation between two quantities, and then write an equation and solve it. And then we'll check to make sure our solution makes sense, if it's reasonable, if it answered the questions. So let's go ahead and look at this example. Again, we're going to read it, looking for keywords, important words, and key phrases. So here we go. The footprint of the Lincoln Memorial is a rectangle. That's important. So we know it's a rectangle. We know a few things about rectangles. In fact, since it's a rectangle, we'll go ahead and sketch a rectangle real quick that we can use. Determine the memorial's dimensions. Well, dimensions is length and width. When we think of a rectangle, it's got the dimensions of length and width. And so we want to find these. That's part of the question, and the area. So maybe I should have written down here, we're going to want to find length. We're going to want to find width. We know that area is length times width. So that's going to be important. That's part of what we're finding. So we're just reading through, looking at this, finding important things. The perimeter is 620 feet. I'm just going to put P for perimeter, 620 feet. And then we have its length to width ratio is 19 to 12. So this is saying the length is longer than the width. So the ratio of the length to width is 9 to 12. So we are going to so we read through, we need to come up with a variable. And we're comparing the length to the width. So we're actually going to let W equal width. So that's going to be our main variable. I kind of wrote that in a different order. It was written second here, but we're going to assign our main unknown the variable of W. And then in the next step, it says we're going to plan. We're going to describe any other unknowns in terms of the variable. So how does length compare to width? Well, the length to width ratio is 19 to 12. So this is 19 twelfths times W. The length is 19 twelfths of W. So we have our two unknowns. We assigned a variable to this one, and then we figured out using this phrase right here that the length is 19 twelfths times the width. Well, how does that help us? Well, we also have this other information that the perimeter is 620. So in a rectangle, we know the perimeter is the length and the width. So these are length and width. That's what those stand for. And I wrote this, oops, I wrote these wrong. So this should be length, and this should be width. So we know perimeter of a rectangle is 2 lengths, the measure of the length, plus 2 times the measure of the width. And we know these couple things, or we don't know them, but we're going to find them when we have this here. So perimeter, which is 620, that was mentioned in our problem, is 2 times the length. Well, length is this 19 twelfths, W, plus 2 times the width, which is just W. And now we're to a pretty simple equation we're going to solve. So we have 620. We came up with a relationship because of perimeter, and we're going to solve this equation. 620, 2 and 12 reduce. So we have 19 sixths W I'm going to kind of think ahead here and realize, well, I have sixths here, so I'm going to want to have sixths over here. So I'm going to multiply this thing by 6 over 6 so we can have a common denominator. And this is 12 sixths W. We can add like terms here, so we still have 620 over here is 19 sixths W plus 12 sixths W, which is 31 sixths W. And to solve this, we have a fraction here, so we're going to multiply both sides by the reciprocal to solve for W. This we multiplied by the reciprocal, so it would reduce on the right side. So we have W. And on the left side, this works out nice because 31 does go into 62. If you didn't know that, you could just do 6 times 620 divided by 31, but we can reduce here. 31 goes into this 20 times. 6 times 20 is 120. So our width is 120 feet. We're partway there because we found the width. We can now pretty easily find the length because length is 19 twelfths W. So we found our width. Now our length is equal to 19 twelfths times W, which we found was 120. Again, works out nicely. 12 and 120 reduce to give 10. So the length is 19 times 10, so 190 feet. So we found our dimensions. That was the first thing it asked for, find the dimensions and the area. Well, we know area is length times width. So we can find that with the simple multiplication problem. We have area is length, which is 190 feet, times width, which is 120 feet. Multiply those two together, and you get 22,800 feet squared. And we answered each of the questions. Makes sense. We could plug back and make sure this is 620 feet. For our perimeter, we have 190 plus 190 is 380. 120 plus 120 is 240. 240 and 380 do add up to equal 620. So that's a check because we can go back and check if the perimeter is correct.